So if you remember this, then you might remember some of the old movies such as Da Vinci Demons, I believe, or you can remember something like the English movies such as famous as Angels and Demons. So you might be wondering what this is. In the previous days, mostly famous by Leonardo da Vinci, who actually went ahead and created, I can say, as the first ciphertext. He was the first one to go ahead and pass different messages secretly during the Florence Wars and a lot of other stuff. So you might be wondering that how this exactly would come in help. So in the previous days, there was not much thing like if you go some password or something. He used to go ahead and create different types of cipher, and there were different type of liquids inside a specific. Let's say, as you can see, this is printer, but there is another thing in which the paper was written something like this, and you will need to go ahead and decipher all the keys in a proper way. If you are not able to do that, then there would be a liquid over here which would directly go ahead and surpass to the actual paper in which the note was written, and the note would straight away burn, or there won't be anything left of it inside. It can be acid, or it can be any phosphoric acid or something like that. So it will straight away go ahead and get burned, and you won't even know what was the message exactly. So you need to know the password, else the message would completely destroy itself, and you cannot even go ahead and force open it from either end, because again it is protected. So any kind of tampering with that, and it will still straight away go ahead and again throw away the liquid on the paper in which the message was written. Even the paper was a specific type of paper in which you cannot actually go ahead and write any random thing. So that's how ciphering was done in the previous days. So the most ancient and the basic problem of cryptography is secure communication over an insecure channel. Let's say, for example, party A wants to send, let's say, party A wants to send a secret message to party B over a communication line which may be tapped by an, let's say, party C or an adversary. The traditional solution to this problem is called private key encryption. In private key encryption, A and B both hold a meeting before the remote transition takes place and agree on a pair of encryption and decryption algorithms. That's, let's say, for example, in our case, let it be E and D. E is encryption, D is the decryption, and an additional piece of information, let's say S in our case, will be kept as secret. So we shall refer S as the secret key. So to be more precise, A wants to send something to the party B without it to be tapped by the adversary C. So it goes ahead and uses the encryption E and the decryption key D, and it uses the secret common key that known as S. So the adversary, which is C, may know that the encryption and the decryption algorithms E and D which are being used, but it does not know S is the secret key. So after the initial meeting, when A wants to send B a clear text or a plain text message over the insecure communication line, A will encrypt a specific clear text by computing the cipher. Let's say, for example, C equals to E into SM, and it will send it to B. And upon receipt, B will decrypt it C by computing again message equals to D S of C. So I'll just go ahead and write it down for you so that it will be easier for you to understand. So A will go ahead and compute the ciphertext by typing C, not exactly C. I'll just go ahead and let's say for example, C M is our message, and E is our encryption key, and S is our secret. So let's I will take X as the ciphertext. So I'll text X equals to E of S comma M. So this will be the ciphertext that he will be sending, and the decryption key that B would be receiving would be something like M equals to D of S comma X. So the line tapper or the adversary who does not know X should not be able to compute the M from X. If he is able to, then this would be of no use. It will be total waste. So this is how it works exactly in reality. But in the previous time, the Arabs, they generalized this idea to the monoalphabetic substitution, in which a keyword is used to permute the cipher alphabet. So I will write the plain text in lowercase letters and the ciphertext in uppercase. So and it will be something like I'll just go and show you. I have one with me right now, so I'll just let me check if I have used that. Perfect, I'll show that later on. So the ciphertext would be something like CYAN space RWSGKR space AN space AH and RHTFANY MSOYRM OYSH SMSEAC NCMAKO. Okay, so when you go and look at this specific thing, you will not even recognize what it is exactly, but breaking ciphers of this kind is straightforward pencil and paper puzzle, which you may have done in primary school. The trick is that some letters and combination of letters are much common than others, and in English most common letters are E, T, A, I, O, N, S, H, R, D, L, U in that order. So artificial intelligence researchers have shown that interest in writing programs to solve monoalphabetic substitutions using letter and digraph that's letter pair frequencies alone typically succeed with about 600 letters of ciphertext, while smart strategies such as guessing probable words can cut this to from 600 to 150 letters, and a human cryptanalyst will usually require much less, like approximately around 50 to 75 letters, and it will probably go ahead and actually crack this word. So if I go ahead and try to crack this, so it will be something like, it will be I. So I will replace everything with I, and or rather than that, I'll just go ahead and show you an example. You can go ahead and try to crack it. This will be this. So you can go ahead and replace the CYAN that we had and replace every C with T, Y with H, A with I, and N with S, and you can straight away go ahead and try to crack this key. So this is an example as to how it was during previous days. So yeah, that would be it for this tutorial, and that's how it works. In the next tutorial, I'll be teaching you about the two different ways of making a cipher, and how how in the previous days they used to go ahead and communicate through this type of plain text.